Hey guys, Professor Floyd here with OEH 5723, homework set 7, problem number 4. This is just a real basic problem where I'm trying to get you to refresh your memory on balancing chemical reactions. So here we have the balanced reaction for the full combustion of benzene with air, with oxygen in air, and then methyl tert butyl ether with oxygen in air. So the formula for benzene is C6H6, reacts with oxygen, remember oxygen is a diatom, forms water and CO2. So I guess if you had a low temperature flame you might form some PAHs and other things, but we're assuming you have complete combustion. It's nice high temperature incineration. So carbon is only coming from this one species. We have 6 of them, and carbon is only accounted for in this species. So we must have to have 6 CO2s. Hydrogen only comes from this. We have 6. Hydrogen is only present here, and it comes in pairs. So we need 3 pairs to make 6. Now we have oxygen from 2 species, but only oxygen left from 1, so we should be able to account for it. We have 2 times 6, we have 12 oxygens, plus another 3. So 15 oxygens. So we need 15, and they come in pairs. So we need 7.5 pairs. Now in chemistry, a classic balanced chemical reaction, you wouldn't have half moles. You would recognize that you're going to have 2 moles of benzene so that you don't have any half moles. Because that's looking at this as being an actual molecular interaction. You can't have 7.5 molecules of oxygen. But when you're talking about large-scale combustion, you certainly can have half of a mole of oxygen. So we're not going to worry about getting rid of all of our decimals or our fractions. This is a balanced reaction. That's good enough for us. So then if we take methyl tert butyl ether and we react it, we see that we have our carbon source is the MTBE. There's 5 carbons, and the only place that we can form carbon is CO2. So we'll have 5 of those. We have 12 hydrogens, and the only place that we use hydrogens is with water. So we'll have 6 of those. And now we've got oxygen in 2 places, but that one's fixed. So we have 5 times 2, 10 oxygens, plus another 6 oxygens. So we have 16 oxygens. Over here, we already have 1 oxygen. So we need to account for 15 more. And they come from diatomic oxygen, which comes in pairs, just like above. So 7.5. So the same reason applies that I said earlier. We're okay with having half moles here because a mole is a large quantity of molecules and it can easily be divided in half.